talk to you about and show you today is Anura, our voice control autonomy software. So very simply, Anura allows a warfighter to task a drone by simply talking to it in natural language, much like he would talk to another teammate if he was giving them a task to go search an area. I think it's useful to start with what problem we're trying to solve. The problem as we know it today is cognitive overload. It is difficult to employ uncrewed systems like drones or ground robotics in dynamic, complex environments that warfighters have to serve in. The problem is growing into what we call the big robot problem. And that's kind of what we see on the horizon. The big robot problem is kind of an evolution of the last 5 years where drones and other robotic autonomous systems have become ubiquitous across the battle space. The next 5 years and 10 years, we really see no slowing of that trend, right? It's going to accelerate. You're going to see more and more uncrewed systems, higher numbers, more complexity, more advanced sensors, multi-domain platforms, heterogeneous platforms being employed in very complex ways. So with all those new capabilities comes some inherent challenges. And the challenge is, how do we make sure that we don't overwhelm the individual soldier or Marine with all of these advanced capabilities? Having served myself, I know how hard it can be to employ one of these things well when you have a lot of other tasks going on, let alone, the future ConOps that we're seeing of many systems all at once, very tightly integrated. So we think that there's a demand for less cognitive burden, less specific training on every new platform, a larger span of control so that I can reach out and with a little bit of input, achieve a lot of effects using these systems. So that's kind of the problem that we're targeting. And it's a problem that makes current operations difficult, but it has the potential to make future operations and future ConOps impossible if we don't restore that human to how we're designing this system. So how does Anura work? Anura works by translating natural language into commands that a sensor, an aircraft, a ground robot can understand and go carry out. So there's two parts of our system, the voice control aspect and the autonomy aspect. We're very focused on extracting the intent from that operator's verbiage and translating it into something to carry out a very difficult mission like a route reconnaissance, a searching an NAI, which is a named area of interest, flying to a given objective, orbiting a given objective, tasking based on a direction and a distance from my position. These are all things that are very familiar to the military, but they're difficult to achieve with uncrewed systems today. I kind of talked a little bit about how it worked. What is the so what behind this technology? So what you're going to see today is my colleague over here, Jordan, is going to use Anura to voice fly this nano UAS. It's about 7 grams. It's an awesome piece of hardware. And you can imagine this is a Teledyne FLIR Black Hornet 3. You can imagine that when you're employing a drone this small, it's very complex, it's very chaotic, you're very close to an objective. So you can think about all of the different manual inputs that would be needed to control this today and how it's easier to do that with voice. Another thing about our system to note is that there is no large language model being used. You don't have to have reach back to, a server somewhere or an API call. All of the compute is happening right on his body, and it's all happening in real time using the common operating picture that he's familiar with as a SOCOM operator, which is ATAC. So just kind of a quick orientation. You'll see he's got body-worn compute hardware on his side. That's a Tomahawk Robotics KXM. All of the AI and machine learning is happening right there. He's got his chest-mounted phone where he's got his common operating picture for his mission. And then he's got the Black Hornet 3, which is the little guy here that's hovering just to his left. So with that, I'll turn it over to Jordan, and he'll kind of walk you through what system looks like.
Thanks, Mick. Can you hear me all right? Good. So my name is Jordan, senior product manager here at Primordial Labs. Before this, I was in the Marine Corps with Mick actually for about 10 and a half years, most of which with MARSOC. And on the team, there's element leader, CQB leader, master breacher, Hearst master, assault climber, mortar leader, and I flew all the SUAS systems like this guy right here. It's hard enough to keep, current on your day job, let alone know 5 different drones. Usually forgot most of them. So one thing I really like about a Neuro is just it's one thing to kind of control them all. I'm going to show you here now the first sequence of commands, essentially. We'd like to call compound commands. So something that would take normally an operator a lot of stick input, just verbally, and it's very quick and easy, kind of fire and forget. Go up 8 feet, then move right 10 feet, then look at alpha, then zoom in. So tomorrow I'll have hopefully all this screen mirrored so you can see the common operating picture. I placed a point on ATAC called alpha. It's basically the Palantir booth, but you should be able to see the video. And then there it is. So very, very simple. Give it a series of commands. It's going to be anything, direction, distance. I need you to go 500 meters northwest of my location and search, something similar to that. Or we can do look north, then move forwards 5 feet, then look right, then set the camera to 45 degrees, then zoom out. I'm just making it up as I go. Something that would I wouldn't be talking to you. I'd be on a controller trying to do it. But outside of the net, if you can kind of imagine this being used at a grander scale. But besides kind of the things I showed you here, you can do very, very simple commands, anything from lateral movements, cardinal directions, elevation changes, come down 3 feet. You can task the sensor, set the camera to 20 degrees. And then you can also place points from a Neuro to where it's looking, where the sensor is looking, or manually place those on ATAC. So I place a few points on here. You'll see if you're here tomorrow. We'll get the screen share working. But I can, wherever I'm looking here, drop a point here called Zulu. And that'll automatically populate right on ATAC, and then vice versa. You can also remove them. Remove Zulu. And then you can string them together, so you can use a route building tool on ATAC, or you can just have a couple of points, fly route Echo Delta. This will just be the end to the end here, the page. There's also mission type orders, and I'll get into those in a minute. Actually, there's referential commands, which basically direction and distance from a known point. Stop. So I'll do a look, kind of a sensor command for that. Look 50 feet south of alpha. Let's see if that's where kind of we are a little bit. Now you can do the same thing with the operator location. Look X amount away from me, move 1,000 meters northwest of my position. The mission type orders we have are search and orbit, and production release will have offensive and defensive scans, spiral in, spiral out. But I can do a little search here. Search your current location with a radius of 6 feet. And you can give it a radius. You don't have to. It'll default to like 150 feet. It'll basically, for the search, it'll ping pong in this magic circle that the radius that you gave it. And then with the orbit, it's the same thing. You can orbit where it's looking, where it is, where you are, where that point is, you name it. And then a big thing I want to highlight too is the fire and forget type piece, because like for me, I'm talking to you guys, but people who are actually out doing things probably have to use your weapon system, and you can just task it, hey, go do this. And then you'll get a notification when it gets there or starts the search or starts the orbit. Hey, look at your phone. then you can flip the phone down and you're not sucked into a controller the whole time trying to fly the aircraft. But Mick, back over to you. That concludes it. I'll take this thing down. Thanks.
Yeah. Thank you, Jordan. What I want to highlight is, everything you saw is kind of constrained by our environment here, right? Pretty small radius, but we're on 7 different drones right now, all up to the Group 1 space. We're on a ground robot. And you can imagine when we're in a field environment with routes, checkpoints, objectives, areas of interest, you can imagine the power of being able to verbally use the language I, as a warfighter, already use about my mission to task my uncrewed system. So now we're putting the warfighter in a position where he's not a buttonologist. He's not learning specific bespoke knowledge for each platform. He's thinking about tactics. He's thinking about how to employ these systems very naturally in a very expressive way to get a lot of output. There's value in this small UAS space we're doing now, but we're also working on launched effects, bringing this into support helicopter pilots controlling drones, controlling multiple drones at once. So you can kind of see how the power of this interface really accelerates as you get more complexity, bigger platforms, more platforms at once. And we really believe that, natural language scales in a way that buttons and joysticks are going to have a really hard time to do. So that kind of concludes our brief. Love to chat with you guys about your mission areas or just about the technology. We're over at booth 423 and we'll be hanging out here as well. So thank you very much.